Stop obsessing over prompts. The smartest AI teams are focused on something far more powerful. That's context engineering. If you're still treating prompts as the secret to AI, you might already be ahead. We will have a look how AI interaction has evolved. In 2020, basic prompting focused on asking questions and refining wording to improve outputs. By 2021, few short prompting demonstrated that examples could significantly improve model performance. In 2022, chain of thought prompting introduced structured reasoning, enabling better results of complex analytical tasks. During 2023, advanced prompt frameworks emerged, combining roles, constraints, templates, and multi-step instructions to improve reliability and consistency. The major shift occurred in 2024 with AI agents. Models were no longer limited to generating text. They could invoke tools, execute workflows, and interact with external systems. By 2025, the focus began moving from prompt engineering to context engineering. Instead of optimizing instructions alone, practitioners started optimizing memory, retrieval systems, external knowledge, tool access, and contextual information surrounding the model. This significantly improved accuracy and reduced hallucinations. Looking ahead, autonomous AI systems will dynamically manage context, memory, planning, and tool selection with minimal human intervention. The key trend is clear. Prompt quality still matters, but context quality is increasingly becoming the primary driver of AI performance. For years, prompt engineering was considered the primary skill for working with large language models. The assumption was simple: better instructions produced better outputs. While that's still true, the industry is increasingly recognizing that prompts alone are not enough for complex real world applications. Modern AI systems succeed because of context, not just instructions. A prompt can tell a model what task to perform, but it cannot provide all the information required to perform that task accurately. That's where context engineering comes in. Think about this. If an AI assistant needs to analyze an security incident, answer enterprise question, or assist with scientific research, the quality of the response depends heavily on the knowledge, memory, tools, and data available at inference time. The prompt becomes only one component of much larger system. This shift is driving the adoption of retrieval systems, persistent memory architectures, tool integrations, and protocols such as MCP. Instead of manually embedding information into prompts, modern systems dynamically retrieve relevant context when needed. The result is improved accuracy, reduced hallucinations, stronger reasoning, and better continuity across interactions. Most importantly, AI agents require awareness of their environment. They need access to current data, prior interactions, and external capabilities to operate effectively. The key takeaway is simple: prompt engineering optimizes instructions, while context engineering optimizes information flow. As AI systems become more agentic and autonomous, context engineering is rapidly becoming the foundational discipline for building reliable AI applications. At a high level, context engineering can be viewed as the orchestration layer that sits between the user and the AI model. Rather than relying solely on a prompt, modern AI systems assemble the information required for a task before the model generates a response. Let's start with the first diagram. Context engineering is composed of several key building blocks. Memory systems allow the AI to maintain continuity across interactions and retain relevant information over time. RAG, or retrieval-augmented generation, enables the system to retrieve external knowledge from documents, database, or enterprise repositories. MCP, that is, the Model Context Protocol, provides a standardized mechanism for connecting models to external resources and process services. Tool access allows AI system to interact with APIs, database, code execution environments, and business applications. Finally, agent state management track goals, plan execution, and progress across multi-step workflows. Now, look at the second diagram. When a user submits a prompt, the request first enters the context layer. This layer dramatically gathers relevant memory, retrieves supporting knowledge through RAG, accesses connected systems through MCP, and invokes tools when necessary. Only after this context has been assembled in the information and this information is passed to the AI model. The result is a model operating with significantly richer situational awareness. Instead of generating response from training data alone, the system can reason over current information, prior interactions, and external knowledge sources. This architecture reduces hallucinations, improves accuracy, enables long running agent workflows, and forms the foundation of modern enterprise AI systems. In many advanced deployments today, the quality of the context layer has become a more important differentiator than the prompt itself. The impact of context engineering on cybersecurity is becoming increasingly significant as organizations adopt AI powered security operations. Traditional prompt based systems often struggle with incomplete information, leading to inaccurate analysis and potential dangerous hallucinations. In security environments, those mistakes can have a real world consequences. With context engineering, AI systems can dynamically access threat intelligence feeds, historical incident records, internal documentation, SIEM data, and security knowledge bases before generating recommendations. This dramatically improves the quality of threat investigations by providing the model with relevant operational context rather than relying solely on its training data. The benefits extend directly to incident response workflows. Security analysts can receive faster and more accurate recommendations because the AI has access to current alerts, historical patterns, and organizational security policies. Context aware agents can also automate repetitive SOC tasks such as triage, enrichment, log relations, and evidence collection. Perhaps most importantly, context engineering helps reduce hallucinations. Instead of generating response from probability alone, the system grounds its output using verified security data sources. The result is stronger security workflows, improved analyst productivity, and more trustworthy AI assisted decision making across modern cybersecurity operations. Context engineering is also creating new opportunities within quantum computing, particularly in research, education, and scientific discovery. Quantum computing involves highly specialized concepts, mathematical frameworks, and rapidly evolving research literature. Traditional AI systems often struggle because much of this information is either highly technical or absent from their original training data. By incorporating retrieval systems and scientific knowledge repositories, context aware AI can access current quantum research papers, technical documentation, algorithm libraries, and educational resources at inference time. This enables faster research assistance and more effective exploration of quantum algorithms and architecture. Researchers can use these systems to analyze complex topics, compare approaches, and discover relevant literature more efficiently. Students and practitioners benefit from enhanced learning experience because explanations can be grounded in verified scientific sources rather than generated purely from statistical patterns. Another major advantage is reliability. Context engineering reduces the risk of incorrect explanations, fabricated citations, or misleading technical interpretations. As quantum computing continue to advance, context-aware AI systems will play an increasingly important role in accelerating research, improve knowledge discovery, and make highly specialized quantum concepts more accessible to broader technical audience. As we wrap up, it's becoming clear that the figure of AI is moving beyond prompt engineering alone. For years, the focus was on crafting better instructions to get better outputs, while prompting remains important. It is no longer the primary factor determining the performance of advanced AI systems. The biggest Driver behind this shift is the rise of agentic AI. Modern AI agents are expected to plan, reason, retrieve information, use tools, and execute multi step workflows. To accomplish these tasks, they need far more than a well written prompt. They need to access to the right context at the right time. At the same time, reasoning models continue to advance. These systems are becoming better at complex problem solving, but their effectiveness still depends heavily on the quality of information available during inference. Better context leads to better reasoning. We are also seeing rapid growth in multimodal AI. Models can now process text, images, audio, video, and structured data simultaneously. Managing this diverse information requires sophisticated context management rather than increasingly complex prompts. This is why context engineering is emerging as a foundational discipline. Memory systems, retrieval architecture, MCP interactions, tool access, and agent state management are becoming critical components of modern AI applications. Across cybersecurity, enterprise software, scientific research, and education organizations are investing heavily in context aware AI systems. The trend is already visible across the industry. The most capable AI platform today are not simply using better prompts, they are building better context pipelines. And perhaps the most important takeaway is this: the AI landscape is evolving incredibly fast. Technologies, frameworks, and best practices are changing every year. For AI professionals, engineers, researchers, and security practitioners, continuous learning is no longer optional. Understanding context engineering today may become as important as understanding prompt engineering was just a few years ago. If you found this valuable information, subscribe for more AI insights, hit like, and share your thoughts below. What AI trend should we explore next? Let us know in the comments. Thank you.